back to part 3 of learning the basics of trig. So up on the board I have the reciprocal identities of trig. In our last video we went over the 6 trig functions and their identities. So we have sine, cosine, tangent, cosecant, secant, and cotangent. And these up on the board are the reciprocal identities of that. So 1 over sine of theta equals cosecant of theta, and 1 over cosecant of theta equals sine of theta. This is because they are reciprocals. You flip it over and they become each other. So I would write these down. I will try to make like a master list of all the identities because there's a lot and you need to know them to solve them later. But yeah, 1 over sine of theta is cosecant of theta, 1 over cosine of theta is secant of theta, 1 over tangent of theta is cotangent of theta. I wrote that wrong, didn't I? Haha. This one is 1 over tangent of theta. Oopsies. But see, they're all the same. And for like an example over here, we have if sine of theta is 3/5, then cosecant of theta would be 5/3 because you just flip it over and that's how that works. Moving on, we have the ratio identities. We have tangent of theta is equal to sine of theta over cosine theta, and cotangent of theta is equal to cosine of theta over sine of theta. So if you're trying to find cotangent of theta and you have cosine and sine, then you can find that easily, or with tangent. An example would be if sine of theta equals -3/5 and cosine of theta equals 4/5, and you have to find tangent, we know that tangent of theta equals sine of theta over cosine of theta because that's an identity that will never change. That is just known. And then tangent of theta, we would substitute in the sine and the cosine of theta to get tangent of theta equals -3/5 over 4/5. And then if we reduce it all down, we find that tangent of theta equals -3/4. So using these, they're just 2 more simple identities that will help you solve and like use trig functions. These are the Pythagorean identities. It looks like a lot, but it's really not. It's just like the Pythagorean theorem, but with sine and cosine. So cosine squared plus sine squared equals 1. 1 plus tangent squared of theta equals secant squared of theta. And 1 plus cotangent squared of theta equals cosecant squared of theta. And then these 2 at the bottom are just like different forms of this one. You know, I subtracted the sign, like square rooted it and all that. So like you can use these just in the same way we use the other ones, just as identities. So here's an example. If sine of theta equals 3/5 and ends in ⅛2, it terminates in ⅛2, then find cosine of theta. So we can use this 4th identity that I have here. Cosine of theta equals plus or minus the square root of 1 minus sine squared of theta. So then we can substitute in the sine squared and simplify it all down into cosine of theta equals plus or minus 4/5. At that point, we don't know if it's plus or minus, and that's where we have to use that all students take calc trick, because we need to decide if it's positive or negative. So if you look at it, it ends in ⅛2, which is the s, and with the s, the sign is positive, so cosine would be negative. So from all that, we can decipher that cosine of theta would equal -4/5 in this example. So now we're going to move on to proving trig identities. This is, honestly, I'd say one of the most annoying things of trig, because most people, like, you gotta have like the brain, like the working brain to do it. You know, it's like 24 challenge kind of. Like you only have so many things to use, and you have to get that answer. So we need to prove that cosine of theta times tangent of theta equals sine of theta. And we know it's true, but we have to prove that it's true by turning one of the sides into the other side. When you're proving trig identities, though, you can only change one side of the equation. So for me, I'm going to choose to change this messier left side, and I'm going to work on that. So the sign stays the same. I just have to turn this side into a sine. So what I'm going to do is use my one identity. I'm going to use my ratio identity. saying that tangent of theta equals sine of theta over cosine of theta, right? So then we're left with cosine of theta equal times sine of theta over cosine of theta equals sine of theta. And then from here, we can see that these cosines cancel, so if I cross them both out, we're left with sine of theta equals sine of theta. So that's a really easy proof. That's a really easy trig identity to prove. They do get harder in the class, but as you move into pre-calc and calc and all that, you don't really use this as much until like you reach college maybe, but like, you know, just the basics of proving trig identities. There you go. And yeah, that's the end of this video. I hope you enjoyed and have a great evening.